Can you hear me?
Yes, we can hear you
Hello.
very well.
Okay, okay. Um, Hello everyone. My name is Saheed Adewumi. Today I'm going to. This is the third week of our journey to associate cloud engineering, and today we are going to talk about planning and configuration a cloud solution. So for this, we have our agenda. The module agenda, we are going to talk about selecting resources for Cymbal Superstore cloud solution. For those people that are just joining us, Cymbal Superstore is the platform that using for Cymbal Superstore is more of like a store, and we are discussing the second agenda here. We are discussing an diagnostic question, and the last one will be reviewing and the study plan. So, before those people that joined us in the last two class, I believe we are going through the courses and to do some lab, to watch some tutorial on the googlescript.com. And I will advise you, if you are doing all this, try to share it on your social media in order to create awareness so that if you get a certification, you will be recommended, you will be able to add to the community. So moving forward, so this section was talking about selecting resources for Cymbal Superstore cloud solutions. So in this scenario, we are assuming as a cloud engineer, you are expecting to select resources to set up a Cymbal Superstore cloud solution. And this, you have to make sure you do some practice. You have to make sure you use some criteria based on the business. So before we go forward, it says planning and configuring Cymbal Superstore. So to start planning, you have to talk about how to plan and configure the compute resources, configuring data storage options, and network resources. So these are the key three things we are going to be looking into. And here we have this Cymbal Superstore existing applications. So these are the three projects. I mean, these are the three projects they have in Cymbal Superstore. We have e-commerce, we have transportation management, we have supply chain. So before you go on as a cloud engineer, you expect to read the requirements, business requirements. You have to understand the technical requirement at the same time. So here we have Cymbal Superstore as an existing web application that provide an interface for customers to add and other products. So this is typically an e-commerce platform, and the requirement is a complete container architecture. So it has to be like, if you are checking other, and you are going to go together to check, and the data relational the backend. So backend, we are talking about MySQL, Postgre, and all. So we are not expect to use any NoSQL or MongoDB. Yes, this is relational back. Networking needed to be global available, meaning because an e-commerce website, everyone all over the world have to have access to the web application. So here you a network that's not going to be regional. So this networking has to be global accessible. So need an capability to inform market effort system for this e-commerce. So you might need some resources like BigQuery too. So okay, so let us move to the second part. Says transportation management project. It says delivery service is becoming an important aspect of Cymbal Superstore customer interactions. Cymbal Superstore will Google service to keep track of truck loading. So here in this scenario, they are talking about the logistic for Cymbal Superstore. And this is how it works in real life. So if you are working in real life, you are expected to give you what are the stakeholders, what are the projects, what are the people that are working these particular organizations. So the requirement says dashboard of the truck location in a near real time. So you want to be keeping track of the logistics for this Cymbal Superstore. And the second requirements analysis of truck mileage for preventive maintenance. So you want to be track analyze the age of the truck, preventing for maintenance use. So this is the second project. The third project is supply chain. Cymbal Superstore has decided to migrate their legacy supply chain to the cloud. So here they are migrating exist on premise or another platform they are moving to cloud. So this uh, requirements is from local to their headquarter. So meaning their premises and they want to move it. So available to local. Okay, sorry, available to local to HK. They have branches and they want to be getting from the local from this branch to their headquarter. So the second one, they currently implement in virtual machine with Linux operating system and LAMP stacks. So this they have an existing system. So let us move forward. Let's see what. Okay, so we have this a Cymbal solution. So we are reviewing the second flow. So this is first of the e-commerce from the container architecture are using Google Kubernetes engine because it's a container. So container, it will be best to just shift and lift to Google Kubernetes engine. So container Kubernetes engine, relational backend, it has data spanner. So this is the best services you can use. And if you check, you can use other data storage, especially NoSQL. You can use Cloud SQL and all. But the reason why we can't use this alone is because of this criteria, global availability. Data spanner is the only thing that's able to render that services because it has a lot of space, a lot of capacity. And this networking was talking about load balancing. So load balancing is the one like any user from the different region, the load balancing can route to the right server instantly. So this load balancing will be the best option. And it says the last one is analytics capability. So here we are going to be using BigQuery because that's the major use of BigQuery here. So as a cloud engineer, you have to make sure that you understand the existing businesses, the existing business requirements, and able to match it with the perfect um, online resources from Google Cloud. So the cloud solution here has already matched with this. We already know what we are using from the businesses and what resources are we going to use for implementation. So the next option, which is the transportation management solution, we have the dashboard of the truck location in the real time. So we want to be using a live transmission, and the best option you can use is pops up. So this push and subscription is the best option, and the reason for this is that we are going to be getting a return even if there is a loss of network or other thing. It will save it as a query and it will push anytime you are connected. So this is really best option. Analysis of truck mileage for preventive maintenance. So this other thing which is composing using Cloud Run. So Cloud Run, the purpose of Cloud Run is it's very cheap actually, and at the same time it's work according based on the query. So this is cheap and easy and it's auto scaling. Data flow is really well because it's fetching a lot of data. Just imagine you are able to fetch time to time relocation of the trucks. So this data flow will be really transmit and able to send it to the pops up, which is the notification, and the storage table because this data is a no SQL, it's a real time, it's no SQL. You are expect to use big table. So the difference between SQL and no SQL is that one it has structure, the second does not have structure. So this is really helpful for IoT real time like expect to use NoSQL. Depend on the project, but for this scenario, we are using table, and this has the capacity to store millions of data, billions of data at once. So this is the best option as a storage platform. And for the networking, we have the networking because here, if you check this, it says global. This didn't talk about global, so we are using regional. So the networking has to be a regional to save cost. Moving forward, we have the supply chain here. So the supply chain says, firstly, to move to local to headquarter, and also to currently implement virtual machine in with a Linux operation system and LAMP. So in this scenario, you are just expected to use a compute engine. So the compute engine is you just make sure you use maybe you copy all the project and migrate it to compute engine and available local to headquarter. You have to know that they are using the database. The database has to be a relational database because of the relationship between the local and headquarter, whereby we are going to use cloud SQL. And the networking internal to VPC, backend database. So the compute engine and the cloud SQL can be able to communicate. And we have a regional external headquarter access, HTTPSS, for the accessing of the application. So any action performed locally, it can be really get it. We can get it from the headquarter in real time. So these are the requirements, and these are the managed cloud solution. So we have some question here who says, uh, so before we go, we talked about the study. Okay. So before we go, we talked about the study. So we are going to handle some question. Although I will do it at the end of the tutorial, at the end of the section, but this is just we are going to talk about the basic stuff. So planning and configuring compute resources, and second says database planning and configuring database options, and planning the network resources. So here we are going to talk about different computing resources we are going to use whenever we are managing and networking resources options. So here we have planning and configuring compute resources. So whenever you are trying to work on compute resources, you are expected to use consider this selecting appropriate compute choice for a given workload. So you have to select your computing resources based on the workload, and using sports VM instance and custom machine type as appropriate. So in this scenario, we are talking about we have different computing resources, compute engine, we have GKE, Kubernetes engine, we have Cloud Run, and we have Cloud Run function. So the second one we have using sports VM. So using sports VM, there are some operation. Let me give a scenario. We are use a batch transaction with a compute engine. You can set a sports VM whereby it will just based on requirement or customize machine type as appropriate. So we have different type of compute machine type. We have memory based, we have graphics based, we have storage based. So these are the type and choose the right ones. So decide to migrate their supply, you need to configure a specific system dependency. So in this scenario, I think we have implement an application using container on the cloud run. The second option says implement an application using. Okay, I think let me leave this, and I will just come down when after we are done with all the presentation, then we can solve this question so that it will be more exciting. So we have some services. We have infrastructure as a services, IaaS. So these are the service whereby you are expected as a cloud engineer to set up everything, to plan major part of it, and set your project up. So as a infrastructure as a service, a good example. So computer usage and typical use case. So here we have the compute engine is a virtual machine in Google Global Dataset, and we have Google Kubernetes engine. So these two is an IaaS, which is being managed by a cloud engineer. So we have a complete control, ability to make OS leverage change. So we have, as a engineer, you are the one to set up your operation system, Linux, Ubuntu, Mac, any of you are or customized OS. So to be able to move the cloud without that your code. So you can able to migrate it with uh, any application. So because you set it up yourself, you can use with the help of Terraform, you can have to manage your project. So to use a customized VM image, you have an existing virtual machine OS, you can install some instance template with it. So this is the advantage of using IaaS. Any workload requires a specific EOS and or configuration. So in this scenario, typical scenarios, if you have a customized OS, you can install it on that. On-premises software that you want to run in the cloud. Let's say, for instance, you have an existing project on premises, you want to set up on the cloud. You don't have to be worried. You can just set it up exactly the way you have it on your Google Compute Engine. So this is the scenario for Compute Engine and full control of your project. One, we have a Google Kubernetes engine. So if you are familiar with Kubernetes infrastructure, you can use this for your work, whereby no dependency on a specific OS. Oh, sorry about that. Okay. Increase velocity and operability. So this is the benefit of using Kubernetes engine to manage container in a product. Basically, if you are running Kubernetes, meaning you are managing a container, so you are containerize your workload, cloud native distributed system, hybrid application. So these are the use cases whenever you are using deploying a containerized, whenever you are using cloud native distribution system or hybrid application. So let us go back to this. One says Cymbal Superstore decide to migrate their supply chain to Google Cloud. You need to configure specific operation which match this specific operation system. So here we have says implementing an application using container. It should be a JKE, but on Cloud Run. So by the way, you you can run a Kubernetes or containerized project on Cloud Run too. So flexibility compared to JKE, but I will, for maybe in next class we can explain more about this difference between Cloud Run or maybe defender and implement an application using code on App Engine. So this does not give you flexibility to install your operation system dependency. So Cloud Run and App Engine didn't give you the like unlike IaaS, which is infrastructure as a services. This SaaS, software as a services, just want to install, don't have to worry about the infrastructure, just upload your code, they will deploy it for you. Have implement an application using container on GKE. So for this scenario, right, because we need to configure our OS, and it's not stated yet that we are using Kubernetes or using containerized stuff. So here it's just scan works. And the last one is to implement an application using virtual machine or compute engine. So this is the perfect one whereby you just want to deploy dependencies. So this is going to be a best option for this scenario. So moving forward, we have platform as a service. Oh, sorry, is a platform as a services. So we have App Engine, Cloud Run function. This has for the App Engine is flexible zero ops platform for building application, and it's disadvantage to just focus on write code. So if you are a startup, if you are an organization, you just focus on the writing of code. Developer velocity is very fast because you don't have to worry about infrastructure or networking configuration. To minimize operational overhead, so these are the benefits. And the scenario you can use it for website development, website development, app or web app. Of course, if it's not really complicated, you can use App Engine. on your charges is pay for what you use. Support API endpoint, so you can able to use an API to manage your cloud run. And where is work web framework? These are the basic tools scenario you can use that. But if you are working for a startup or your organization,
Uh,
you can scale the infrastructure on the cloud run. So we have cloud run functions or cloud function. So it's a serverless execution environment for building and connecting cloud services. So we have a scenario whereby there are some function you are not, it's an event based. So it's an event driven workload scale to meet demand, minimal configuration. So these are just once in a while operation you want to be running on the infrastructure like auditing or running a big query or other infrastructure that just once in a while or batch batch transaction. Cloud Run will be a bit better tools for that. Static analysis, image thumbnail generation, post of comment to a Slack channel after a GitHub commit. So these are the best scenario you can use Cloud Run for. So you can differentiate this App Engine, Cloud Run, Cloud Function. They all have something in common, which is flexibility. So you don't have to worry about your infrastructure. Just able to deploy your code and they can able to manage it for you and scale up for you. So we have a scenario here says a Cymbal Superstore decided to pilot a cloud application for their point of sale POS system in their flagship store. If you want to focus on code, you can say you want to focus on code and develop your solution quickly and you want your code to be portable. So here they talked about you want to focus on your code. So these are the key things. So you have to use platform as a service infrastructure. So coming back here, SSH into a compute engine VM. So this now we can't use this because it's using compute engine, meaning you have to configure your system by yourself, configure the memory, configure the network. So can be a way for him package your code to a container images and post it to a cloud run. Let's see, uh, implement a deployment manifest and run Kubernetes apply on the Google Kubernetes engine. So this can work. A and C can work. Uh, the code solution in cloud run functions. So this is a point of say. So I will go for B because cloud run is more like we are piloting. So if you check this, you say that listing for requests or events. So this is web framework and which match the requirement. This the different why this is not a good option is that because you were saying the condition says you want your code to be portable. So meaning your infrastructure, everything will be managed, whereby this is an event, you have to based on the event driven. And this is a web application, it's a cloud application like a POS, which is going to be like infrastructure. So this is like a web application microservice use. So we have another top question says application running on a high customized Ubuntu need to be migrated to the Google Cloud. You need to do this least amount of time and minimal code. Anyone can give it. Anyone here following us give an option. Can you just say the option? Can anyone give us an answer for let me present again. So this is our question. Minimal code change, least amount of time. So meaning you have to be fast. You don't have to. Let me see if we have A. Compute engine. So because we says so it's somewhat tricky. Thank you for your answer. So here it says need to do the least amount of time. So if I'm using the minimum amount of time, so we can't use a computer engine because I have to go to my consoles, configure my memory, configure my network, make sure I select install the right OS, which is going to take a lot of time. So this is not going to be A is not going to be a perfect option. And we say here we have three options. To beat these three options, within app engine, cloud run, and cloud run function. So oh oh minimum amount of time. Hold on, I'm wrong. Uh-huh. Yeah. Oh, she's right. Thinking. Yeah, she's right. Oh, so sorry. So yeah, it says let me change. Okay, let's see. Why is A? Migrate. Okay. So we have the Ubuntu, right? Yeah, the Ubuntu. Okay. I was like the cloud run. So let's see the option here. You may be rearranging to current up. Okay. So the correction is the A. Minimum time. Okay. It should be A actually. So thank you very much. You get it right. I'm wrong. Yeah, I get it that now. Ubuntu. Thank you. Yeah, so moving forward, so that's another thing about cloud engineering. You have to make sure that you choose and you have a good reason. So the reason why I'm wrong is because we are using Ubuntu, which is I customized. So this is the what make me busy. So cloud engineering examination is more tricky. You see, they have to conflict. But as a cloud engineer, you have to choose the best option. So yeah, right. We have another says you want to deploy microservice application, you need full control on how to manage your container, reliability, and auto scaling, but don't or need manage control panel. So what is the best option? Let me see if someone can give me a response. Um, Anyone? Let me show you again. Let me see if you can say it again. I know definitely because you have to a containerized platform and you don't want to or need to manage it. You need to fully on how to manage control on how to manage. So it can be cloud run, it can be app engine, it can be C or D. Let me see if they have option A. Okay, let's say so A C. So C says the answer says C. So actually, why I will agree with C is that we have forces. Can you just give me the reason why you choose C so that I will see maybe it's maybe right? Type in the reason why you choose C for your options. So because here we're saying you want to deploy uh, you want to deploy a microservice, you need the control. So this full control means you have to set up your container, you have to reliability on auto scaling, you have to do everything by yourself. So if you remove this, if this condition has been removed, A will be the best option. But here we have you need as a cloud engineer, you need to control on how to manage the container reliability, auto scaling. So this uh C is best option, I think, Google Kubernetes Engine. So let me see if we have any view. Okay, so no option here. So let's move on. And yeah, we have moving forward. So we have these are the courses that are looking into planning and configuring cloud resources. So you are expected to do the core infrastructure. I think we have shared in our last course how to virtual machine and networking. The key we have four courses and two skill badges. Sorry, one skill badges for cloud networking. Cloud networking is a very important thing in cloud engineering because you have to know how to prevent security and how to connect with the communities, container, we have virtual machine, and we have the. If you go to these courses on cloud cables, you can able to understand more better. And going to condition, this document will really help you more idea about it. So we have the second one, which is the second agenda. We have the planning of data storage. So data storage, we have so as a cloud, you are expected to choose some certain products for data storage. We have cloud SQL, we have BigQuery, we have Firestore, we have Spanner, we have Big. So categorically, we can categorize it in three pieces, which is cloud storage, BigQuery. We have structure, no structure, and the storage. So the second, we have to choose storage option. The reason we are choosing storage option, zonal, persistent disk with regional, persistence disk, and we have standard code line. So let us go deep in. So we have two options: the product choice and the choose storage option. So to solve us well, so you sent a question, but don't let us solve it. Let us go to the storage before we come to our question. So we have two type of we have four category of data storage and data options. So first we have relational database, we have relational data storage, we have non-relational, we have objects, we have web. So if you are talking about relational, we are talking about cloud SQL and we have Spanner. So cloud SQL, we have um, we have MySQL, we have Postgre, we have any database management software you have under Cloud SQL. So you can able to install, and they are good for web framework. Running a web application platform, you expect to use a Cloud SQL. And a good example is e-commerce or CMS software. CMS software like a WordPress or basic CMS software. So we have Spanner, good for RDBS scaling or HTTPS. So this is used for like user metadata, ads, financial platform, or uploading metadata. So this panel is just like a bigger version of SQL. So if you are running like billions of data, like a streaming or a fintech a global platform, you use Spanner. So these are two best scenario you can use the relational platform. So both of them are relational because they have a structure, role, and column whenever you are creating the data. So this is for scalable fashion. This is just like a normal project. And we have no relational database. We have Firestore. We have Big Table. And no SQL, so you can call no SQL. We can call it non relational. So they are good for mobile app, web, but they are not really connect together. They are good for IoT for transmission of data, just like the truck stuff we had talked about earlier. So the scenario we use a user profile, gaming state. So this is just to store your data for like a gaming. So nice thing about SQL and NoSQL is that NoSQL does not have really have a particular pattern of data. So you can let's imagine you are create a data set and you want a particular set of data. If it is missing, the SQL will still accept it to unify, will still accept it in DB because it's reaching as a document. But for the relational database, it has to be a particular structure. So that is why we have structure and not structure. For the big book, we have it's just like a scale big enterprise use of Firestore or NoSQL. So this is for heavy read and write events, and it's for art tech, it's for financial, it's for IoT. So these two is like a enterprise fashion and primary fashion. So objects for objects we have a cloud storage. If you are storing your objects like a video, audio, files, images, music, anything related to a file, you upload it on cloud storage. And we have warehouse is for analytics, for analysis of data. This is very useful for data scientists. So some platforms, so as far as warehouse, so from platform we use it for the analysis of the data. So such analytic dashboards. So these are the good example of BigQuery. So you can see we have each scenario where we can be using our infrastructure. So choosing resources here, by now you have the idea of, if I'm going for this is the right option we are going to use. Sorry, right resources we are going to use. So moving forward, we have another. Okay, so let me go back here. It says Cymbal Superstore need an analyzer whether they met quota sales project analysis assigned to run this query are familiar with SQL. So they are needing an analytics. And if you come down here, we talked about analytics where this analytics. So I think that's where we go for query. So if you are talking about relational data for cloud SQL and spanner, for no SQL, we go for Firetop. So here we talked about Cymbal Super Supply Chain Application Frequently Analysis Large Amount Data to inform process and operational dashboard. So before we go this, I know we have not discussed this. So the scenario will be here. So before we go this, so we have storage class and usage scenario summary. Sorry, we have use cases in summary. We have standard linear 9, we have code line, we have archive. So Google Cloud, in their real life, they have this relationship with startup or project. So they are a real life scenario in order to sell. So while you are using a storage class, we have no retrieval cost. We have standard scenario. So the standard scenario is when you use it whenever you want accessing it time to time, frequently. So you are using standard classes for your storage. So all data or so this is a typical use for all data for like fetching data time to time. You are expected to use uh, standard class to upload your storage to standard class. And we have layer 9, whereby you are uploading your data very low cost. So this is when you are saving budget, very low cost, and can accept high per operation. So the minimum of 30 days. So this is not frequent, it's just once in 30 days. These are the scenarios. I think the accessibility classified these classes. So if you get one more time, one more than once per month, so no more than once per month. So once in a month you can access this. So this is really good for batch or monthly auditing of your project monthly. Linear storage class it's not costly, and we have code line which is 90 days minimum storage. So you can only access it 90 days. So it's even lower compared to the first two. So and it's only for like for disaster recovery is e-commerce and be backing up on a cloud line whereby just accesses once in a while. And we have the lowest, which is the once in a while, once in a year, which is data archive, online backup, and data recovery. So these are the classes we have. We have standard, we have linear, we have archive. And here, this question says, a superstore supply application frequently. So frequently means they are going to be using standard every time for easy accessibility. So we have another question here. Says, Cymbal Superstore has a need to populate board with the database that is an analytical use case. So I think Sean should give us uh, a solution to this. Like, what is the best option? Anyone? Or let's say if we can get someone. So let me check again. Alessandra, are you there? Okay, so when we are still, uh, we can say, let's say, analytics for populate visual dashboard, which is historical time-based data and it's an analytics use. So yeah, we have this. So the first one says visual dashboard for historical time base, which is the real-time IoT. So it's big table for NoSQL, it's a historical time base, and we have analytics, which is BigQuery. So these are the two options we can use for our real-time chart. So moving forward, we have compression storage option. So if you are using Firestore, so these are the services available on Google Cloud that you can use for your uh, we have Firestore, we have Digtable, we have cloud storage, we have Cloud SQL, we have Spanner, we have BigQuery, and these are the type of project they can handle. So the Firestore, for instance, can handle NoSQL documents, and we have Digtable to NoSQL white column. So these are the types scenario, and they are best for storing synchronized query data and flat. For the big table, they are used for flat data, heavy read write event analytic data. You can use for analytics and my for heavy data. And the use case as I've said earlier, mobile and web, server development, web, big table, and IoT data. For cloud storage is Bootstrap, which is for using for uploading structured data. So it's used to upload images, large media file or backup, or even some storage file you can upload it to your cloud storage. We have Cloud SQL, Spanner, and BigQuery. So these are SQL, and this is for web framework. Cloud SQL you can use for web framework existing application, just using credentials, ordering, and normal SQL information. So we have uh, large scale database. So this is just like a big data of Cloud SQL, just an enterprise of Cloud SQL from large data application, which is more than 2 terabytes. Whenever IO global consistency necessary. So that the typical use, whenever you need the consistency, you can use IoT. And it has some other features to go deep in Spanner, it can able to do piping for you and availability for the global use. And we have the last one, which is the interactive query of analytics use, and a good example is data warehouse. So for analyze, and this is very useful for the data science scientists. So moving forward, we have these are the courses available online that you can see on CloudScape for storages and this service storage and database services. So we have 3 courses, and we have skill badges, and we have documentation. So we have another sensitive is the data life cycle. Data life cycle is there are some scenarios as a cloud engineer you can configure your infrastructure whereby if you get a data and the data is not being used for over 30 days or over 90 days, you can move it with your infrastructure uh, knowledge, automatically move it to the next class so that it will save your customer or save your project cost. And we have the last one, which is the networking, planning and configuring networking resources. We have load balancing. So if you are in network and resources picking, you have to conduct balancing availability of the resources in a network. Sorry, availability of resources location in a network service tier. So we have different data center all over the world. We have in Europe, we have in US, we have in uh, France. So based on the infrastructure you're setting up, you have to choose the right platform region. So yeah, we have this option, but I'm not going to go there now. Let us move to type of load balancer. So we have different type of load balancer. So if I mention load balance, what's load balance? The way it's anytime you push a lot of requests to the server, the load balancer will receive it and distribute it to decide maybe deploy it to send a request to server A or to check the status of the platform before giving your response. So we have two type of load balancer. We have application load balancer. So this is the type of use on more of like a cloud run on our application, and we have a network load balance. This is within communication within the resources is for application. So under here we have external and internal, and for external we have global, and for internal we have regional and cross region. So here, for the global external application load balancer, this means it can work on irrespective of region or zone. So this work in regional external load balance, application load balancing. This work within the zone. So because we have hierarchy, we have the global, we have regional, we have zone. So it's work zone, and we have for this internal, we have the internal load balancing, regional load balancing across region. So within the region, we are able to communicate. So for the load balancing, so and we have, oh, sorry, we have a protocol HTTP and HTTPS. So you can use this load balancer to communicate more of like you are using deploy your API backend. Cloud Run used as a traffic network whereby you can able to deploy on if you're able to deploy on run the capacity to manage your load on your infrastructure. So we have the network balancing is using the protocol of TCP, UDP, and IP, other IP protocols to communicate. We have and we have pass-through, and we have external and internal, and same for pass-through. And the only difference is the network configuration. So if you are configuring your application for global network, it's able to have access. So this is based on the. Can you see my screen? Still something stop sharing. Okay, sorry. Okay, can you see my screen now? Okay, okay.
Yes, yes, we can
So
see.
yeah, okay. Thank you. So yeah, we have what Google Cloud Load Balancing option run as layer 7 of the TCP stack. So here we have, by the time you go through these courses, you are going to be learning more about the infrastructure for the people that are familiar, like just beginner for this. So this layer we have like networking config. This is typical in networking courses, talking about how you can able to configure. So this talked about layers. We have different type of layer, IP TCP layer. So this we're talking about TCP layer, which is a global load balancer. So this, if you go through the to understand this layer stuff, so I will need to go because I don't want to be more confusing. But if you go through the course, you will understand what application layer we have. Also networking layer. We have all these layers, I think 7 to 5 layers, whereby you can able to see their own functionality. Presentation layer, yeah. So all those layers is what you are display as a cloud engineer so that you can choose the right resources for your infrastructure. So we have these are the questions here that we've been talked about. So I think we have one question here. So this says, a Cymbal Superstore is piloting an update to an e-commerce application for the flag store in municipalities and Minnesota. The app is implementing as a three-tier web services with traffic originates for the local area and resource dedicated for its US Central One. So this application we are targeting particular. You need to configure a secure low-cost network load balancing architecture for it. So here we are talking about we are talking about a regional system because you just like US Central One. So and so you are not expected to use a global region here. So this we go through this implement a premium tier. So this is not going to work because it talked about low cost. So by using premium tier global expensive, but this is not going to be advisable. Global external proxy, yeah, this is not going to work because we are talking about regional. So this regional US Central alone, and it's between this region different zone. this is going to work. So configure a standard. So standards is more of, we have two types of resources. We have standard and premium. So here it's falling line and it says regional external application load balancing connect to the web tier. I think C is going to be option. So configure, let's check the configure regional internal or uh, configure regional internal proxy connected to a web tier frontend. Okay. So yeah, I see is the best option here because of the standard. So internal proxy, because this is a web application. And if you check here, we check here, we have proxies for networking load balance and an application actually. So in here, which is you can't use proxy because this is an application. So it's an application, not a network infrastructure. So we have so we have another check. So I think if we can check do this together, it will be nice. Which storage class is designed for long time storage, has 365 minimum storage element, and lower storage price as compared to other storage? Anyone? Let me see. I have an answer D. So let's say, yeah, you get it right. Actually. So because class standard is instantly time to time, yes, which is 30 days, we have which is, and this is 365 days, which is a year. So archive is the best option. Thank you very much for that. So let's go to next. It says which serverless option is based on developing and executing small snippets of code? Which of these serverless option is best on developing and executing small snippets of code? So I know it's not BigQuery, I know it's not data flow. So let's say one. Uh, okay, nobody keeps here. So SRE should be a function because it's the minimum serverless option. So we have App Engine, we have Cloud Run, and we have Cloud Function. So it will be Cloud Function because it's the minimum small bits of code. So I think we are really in this section. And thank you very much. If you have any question, let's see if we have any question and see that question.